David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. Today's lesson involves solving quadratics by the process we call factoring. You've already seen a little bit of that in the last couple lessons. So today we're not going to look at graphs of quadratics at all, but we are going to do some steps and practice some techniques that will allow us to do things quickly and easily with the graphs. So this should be review for you. My hope is that you had factoring in a previous year or two, and that this will be a nice quick tour through several of the different techniques we use to factor quadratics. So let's get started. What this means, it means to find the value of x for which f of x equals 0. Okay, so that's what we do when we solve quadratics. So you're going to see we're going to take a quadratic expression, set it equal to 0, factor and solve. That's the basic process. What this means, you'll see this language, is finding the function's roots or finding its zeros. And what this is, in practice, related to the graph, is that what we're doing is we're finding the x-intercepts. So let's take a quick look at a graph, and I'll show you what we mean by that. So over here I've sketched a really rough graph, and you'll see I've marked the intercepts. Those are the zeros, or the roots, because f of x, the y value, when the function crosses the x-axis, is 0. So the function's zeros are the x-intercepts. And we like to call those the roots of the function as well, although that word doesn't quite have a precise mathematical meaning. Zeros is a little bit better. So that's the context, that's the graphical context. We're not going to graph anything today, but ultimately we will use this process to find intercepts and help build graphs. Here are the steps. 3 quick little steps. First thing, set the function's equation equal to 0. So we're not going to write f of x equals some quadratic. We're going to write some quadratic equals 0. Typically, we put a 0 on the right-hand side, leave the function on the left-hand side. Second thing, factor the non-zero side. So take that quadratic and factor it. Today we're going to look at 3 techniques for factoring. There's the product sum factoring process, there's the difference of squares, and there's splitting the middle term. Now I have other videos that go into all these processes in detail with lots of examples. I'll put links below in the comments so you can check those out if you need to do some reviewing. So we do 1, 2, factor the non-zero side, then we set each factor equal to 0 and solve for x. So as we go through the examples, I'm just going to keep doing these 3 steps, solving for x and getting my solutions. So here's an example. F of x equals x squared plus 5x plus 6. First step, set the quadratic equal to 0. X squared plus 5x plus 6 equals 0. Now this one's a product sum. And the way I know is there's no number in front of the x squared. So now I need to test to see if it's factorable. Not all of them are. I'm looking for 2 numbers that multiply to 6 and add to 5. And those numbers are 2 and 3. 2 times 3 makes 6, 2 plus 3 makes 5. So I've got 2 and 3, so that basically makes my factoring come out like this. Now, I've skipped some explanation there because this is assumed prior knowledge that you can factor a trinomial like this that doesn't have any a term in it. This would end up being x plus 2 times x plus 3. Now, if you FOILed this, in other words, if you expanded it back, you would get back to here. So if that is something that seems new to you, then you definitely want to review the product sum factoring technique. So that was step 2. I factored my non-zero side. Step 3 is set each factor equal to 0 and solve. So this is what I call the branch. I'm going to branch out here. X plus 2 equals 0, x equals negative 2, and branch there. X plus 3 equals 0, x equals negative 3. So there are my 2 solutions. We typically write them like this, as the set of these 2 numbers, using my curly brackets. Now, if you have this technique mastered, you might not show all of these steps, and that would be fine. Do show some steps, however, because some of the credit on IB questions is awarded for showing your work. All right, here's another one. Now, this one's not a product sum because I have a number in front of my x squared term. In other words, A is not 1. In this case, A is 2. So this one is a split the middle term factoring. Now, if you feel ready to do that, what I'd like you to do is go ahead and pause the video and try to factor that and find your solutions. Here we go. So the first thing we do with these is we take the A term and we multiply it by the C term. AC equals -8. Now we find two factors of AC that add up to -7. And that would be -8 times 1. -8 times 1 gives us -8, and -8 plus 1 gives us -7. So that's how we split the middle term. So I'm going to have 2x squared minus 8x plus x minus 7 equals 0. Now, I can take a common factor out of here and a common factor out of there, and what should be left should be the same if I've done this right. So I notice I have a 2x in both of those. So I can go 2x times x minus 4. Now, whoa, I have x minus 4. I already have x minus 4. So what can I do here? I can factor a 1 out of this. You can factor 1 out of anything. And I have plus 1 times x minus 4 equals 0. Now I have two factors are going to be 2x plus 1 times x minus 4 equals 0. Now that's splitting the middle term. Now I take each factor, I do my branch, set them equal to 0. 2x plus 1 equals 0, 2x equals -1, x equals -1/2. Branch this way, x minus 4 equals 0, x equals 4. My solutions are -1/2 and 4. Now you might be able to do this in fewer steps, and that's fine, but show your steps. If this was a 3-mark problem and you just went right to here, you're going to get 1 out of 3 marks. You need to show some work. All right, let's do another one. F of x equals 16x squared minus 9. This is a quadratic. There is no x term. There's no b, or b is 0. So that's 0x minus 0x, and we don't need to write it, but it is there. How might you factor that? This one is a different pattern. Remember, we've done product sum, split middle term. Now this is a different factoring pattern. Pause the video, see if you can remember that. This is what we call a difference of squares, and it fits this pattern. One thing squared minus a second thing squared, in this case a and b, is going to be first thing plus second thing times first thing minus second thing. That's the pattern that we could use to factor something that looks like that, and it's called the difference of squares. This is a difference of squares. It might not look obvious to you, but take a look and see if you can rewrite that as one thing squared minus another thing squared. So 16x squared is the same as 4x squared. And then 9, of course, is 3 squared. So now I have one thing squared minus another thing squared. Go ahead and apply that pattern, factor it, and solve it. So here we go. I factored it according to the pattern. I get 4x minus 3 times 4x plus 3. I do my branch. I work my algebra. On one side I get -3/4. On the other side I get +3/4. So here's how I express my answer in set notation. Now there's another way to do this one that I think I should show you. If we go from this step, what we can do is we can add the 3 squared to both sides. So now I have 4x squared equals 3 squared. Now I can take the square root of both sides and get 4x equals plus minus 3. Remember, 3 squared has 2 square roots, plus or minus 3. And then divide through, and I get x equals plus minus 3/4. So I got to the same result, but instead of factoring, I just went ahead and moved it over and solved it like a regular equation. Both ways are valid. All right, let's try another one. Here we go. 9x squared plus 6x plus 1. Now this one fits a very special factoring pattern similar to difference of squares. So if you want to dig deep, think and figure out if you can remember what pattern that is. All right, this is a perfect square. Might not look like it, but we're going to rewrite it in a minute and you'll see that it is a perfect square. The pattern is, if you have a plus b squared, in other words, one thing plus another in brackets squared, the result is going to be first thing squared plus twice first thing times second thing plus second thing squared. And this is called a perfect square. Now this can be rewritten to make it show that it fits that pattern. So go ahead and do that. So what I've done is I've rewritten 9x squared to 3x squared. I've rewritten 6x as 2, which is part of our formula, times the a, which is 3x, times the b, which is 1, plus 1 squared, second thing squared. So that shows that that is perfect square and fits the pattern. So go ahead, pause the video, use the pattern there to factor and solve. All right, let's take a look. I got 3x plus 1 squared equals 0. That's using the perfect square pattern. My first thing plus my second thing, first thing, second thing, squared equals 0. So that's the factorization of this perfect square. Now, I think perhaps the crux of this is remembering to recognize the patterns. You could factor that with a split the middle term and it would work, but this is much, much quicker. So now I just take the square root of both sides, and we can take the square root of 0 all day long. It's just 0. So now I have 3x plus 1 equals 0. This ends up being x equals 1/3. Notice how I don't have a plus or minus in this case. So I only have one root, or one x-intercept. Square root of 0 is 0. It's not plus or minus 0. All right, let's mix it up a little bit. No new techniques, but a different starting point. So check our function out here. F of x is 3x minus 4 equals 16x plus 8. So now I have a function that actually doesn't have one side set to 0. So I need to do that first. So what I'm going to do is I'm going to rearrange this function so one side's set equal to 0. Now, if you're feeling bold, pause the video and do that and come back. Okay, all I did is I subtracted 16x from both sides and subtracted 8 from both sides, and that gave me this function. So now we can just factor that. So what I want you to do, pause the video. Perhaps if you're not sure which technique to do, flip back through your notes, review all those processes, and factor and solve this quadratic. Okay, let's see how you did. So I split the middle term with two numbers that multiply to a times c, which is minus 36. So 2 times negative 18 makes minus 36. And these two numbers together add up to the minus 16, which indeed they do. Then I factored out the common factor from each of these pairs of terms, and I rearranged to get 3x plus 2 times x minus 6 equals 0. I branched, I got x equals 2/3, that's a minus 2/3, and I got x equals 6. So my two solutions are negative 2/3 and 6. One last example. Now I want you to pause the video and see what you can do with that. Work on that, find your solutions. Okay, let's see how you did. Now you might have taken different steps than I did algebraically, but if you got to these solutions, you're good. So let's take a look. What I did is I distributed my x on both of those and my 5 on both of those. Just use distributive property, got these two terms here. Then I subtracted both those terms from this side to get them over to that side, giving me this product sum factoring. Here's how I did my product sum. My two numbers are 5 and negative 2. They fit those conditions. So then I just take those numbers and I plop them into my binomials. X plus 5 times x minus 2. Now I know how this is going to go. This one's going to give me negative 5 as a solution. This one's going to give me positive 2. So there we go. Those are the two solutions. Now thanks for hanging in there. That was a lot of algebra. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.